Assalamu alaikum warahmatullah. Welcome back. This is your brother Wasil. Today I will be delivering the last lesson of this chapter, carbohydrates. So in our previous lesson we studied about we were studying these polysaccharides, and I told you about the homopolysaccharides. Now in this lesson we'll be discussing about the heteropolysaccharides. As told earlier, heteropolysaccharides are those polysaccharides which yield a mixture of monosaccharide units or their derivatives on hydrolysis. Okay, so these heteropolysaccharides are also known as heteroglycans, like these homopolysaccharides are known as glycans. So these are known as heteroglycans. We have a special type of mucopolysaccharides. These are special types of heteropolysaccharides, or a group among the heteropolysaccharides. These are also heteropolysaccharides, and these mucopolysaccharides, they are their repeating unit, that's the repeating sugar unit, it consists mainly of an amine sugar, for example N-acetyl glucosamine and N-acetyl galactosamine, and the other repeating unit is a uronic acid, for example D-glucuronic acid. uh, these uronic acids are formed, for example glucuronic acid, these are formed by the removal of the terminal alcohol, that is the terminal alcohol group, and with the replacement of a carboxyl group. So this carboxyl group adds to the acidity of the molecule, and hence these molecules are also known as acidic mucopolysaccharides. Mucopolysaccharides are commonly known as glycosaminoglycans. That is in your syllabus, glycosaminoglycans. So these mucopolysaccharides are also found in combination with various proteins, where they are known as mucoproteins or mucoids or proteoglycans. And in a proteoglycan, in a mucoid, in a mucoprotein, carbohydrates, it contains up to 95% of carbohydrates, only 5% of protein. These mucopolysaccharides are also an essential component of tissue structure. For example, in tissues, for example, in connective tissue, if we see skin, if we see collagen, if we see this blood vessels, if you see the tendons, they are embedded in a matrix or ground substance, and that ground substance is predominantly made up of GAG, that is glycosaminoglycans. We have very some important mucopolysaccharides, and these one more thing, these mucopolysaccharides are predominantly found in animals only, and plants do not produce mucopolysaccharides. They are only predominantly and found only exclusively in animals. Okay, some bacteria also contain these mucopolysaccharides. And why do they help the bacteria? They help them in invading their this host. Okay, so we have various types of mucopolysaccharides. For example, we have hyaluronic acid, we have chondroitin 4 sulfate, we have keratin sulfate, we have dermatan sulfate, we have heparin. We'll be studying about a few these mucopolysaccharides. Hyaluronic acid is a very important glucosaminoglycan GAG, and it's found in the ground substance of our synovial joints, that is synovial fluids in our joints, and also in the vitreous humor of our eyes. It also forms a ground substance of various connective tissues, like as I said earlier, in the blood vessels, in the tendons. Okay, and this hyaluronic acid is also formed as a gel around the ovum, and it acts as a shock absorber and lubricant in our joints. Hyaluronic acid is made up of since there is a repeating unit in every polysaccharide. So hyaluronic acid, the repeating unit in hyaluronic acid is D-glucuronic acid and N-acetyl D-glucosamine bonded with beta 1,1,3 glycosidic linkage. D-glucuronic acid is bonded with the N-acetyl D-glucosamine with beta 1,3 bonding. The repeating dimer of this hyaluronic acid are up to 25,000, or you may say 50,000 molecules, 50,000 units. There are 50,000 units of monosaccharides present in the hyaluronic acid, or 25,000 repeating units, that's 25,000 dimers, and its molecular weight is up to 4 million. There is an enzyme hyaluronidase. Enzyme hyaluronidase, it hydrolyzes the hyaluronic acid. This hyaluronidase is found in very high concentrations in testes, in seminal fluid, in certain snake and insect venoms as well. This hyaluronidase, it has a very important role in seminal fluid to to help the fertilization, as there is a hyaluronic acid forms a gel around the ovum. So it helps us, this hyaluronidase helps us in the penetration of the sperms into the ovum. Okay. Now I'll be making the structure of hyaluronic acid. It's also present in bacteria. Certain bacteria, it also, like in sperms, it helps us the penetration of sperm. It also helps us in the penetration of bacteria, since our cells have these polysaccharides, mucopolysaccharides in our cells. So it helps us. This hyaluronidase help us in breaking into the cells. Okay. So now I'll be making the structure of hyaluronic acid. So as I told you, I will be making the structure of hyaluronic acid. So hyaluronic acid is made in the repeating dimer of hyaluronic acid is D-glucuronic acid and N-acetyl D-glucosamine. Now I'm making the structure of D-glucuronic acid, that is, it is a uronic acid. Okay, the basic structure is same. I'm making the structure, and the linkage is beta 1,3 linkage. It is beta 1,3. Okay, H OH. It is OH H, and it is H, and here the terminal alcoholic group is repeated with it is replaced with carboxylic acid group. Okay, CO negative, and another monomeric unit of this repeating dimer is N-acetyl D-glucosamine. So making the structure of N-acetyl D-glucosamine, basic structure is again same. There is no difference in the basic structure. Okay, H. Now here is a difference. The N-acetyl, that is what we call N-acetyl group, it is attached here. Okay, it is NHCO CH3. Okay, so it is the acetyl group, and here it is H, it is here H, OH, it is OH here, okay, H here, and H, CH2OH. This CH2OH group in this uronic acid, glucuronic acid, is replaced by the carboxylic group. So now we have to make the bonding. The bonding is between the carbon 1 and carbon 3 carbon. So this is carbon number 1, 2, and 3. So here is the carbon number 1 of this molecule, this carbon number 4. So now the bonding will be like this. There is oxygen group, and it is attached to this third carbon. Okay, it will be attached to this H. Won't show this H. So this is the beta 1,3 linkage. This is beta 1,3 linkage, and this molecule is D-glucuronic acid, and this molecule is N-acetyl D-glucosamine, and this is the repeating dimer. We will show it like this, and we won't, in the repeating dimer, when you show diagrammatically represent a repeating dimer, you won't show this H and OH here. You will show it like this O, and here like this O. ओके, जो यहाँ पर है वैसे ही यहाँ पर भी और यहाँ पर भी, लेकिन क्योंकि ये रिपीटिंग डायमर है, अभी रिपीट हो जाएंगे. सो ये है हमारा, दिस इज आवर हाइलुरोनिक एसिड. Okay, hyaluronic acid. So this is the repeating dimer of hyaluronic acid, and these repeating dimers are up to 25,000, or you say 25,000 dimers, or you say 50,000 units. Okay, 50,000 units, that is monosaccharide units. So now I will be discussing about another important gag, chondroitin 4-sulfate, or simply we call it chondroitin sulfate. It is from a Greek word chondros, which means cartilage. It is an important constituent of our connective tissues, various connective tissues like bone, cartilage, heart valves, cornea, skin, okay, tendons. Structurally, it is somehow comparable with hyaluronic acid, and it is repeating disaccharide in this chondroitin sulfate is D-glucuronic acid and N-acetyl D-galactosamine 4-sulfate. N-acetyl D-galactosamine 4-sulfate. Okay, and bonding also here is 1,3 beta 1,3 bonding also So I will be making this structure. Why do we call it 4-sulfate? Because there is a sulfur group at carbon number 4 of galactosamine N-style D-galactosamine. Okay, and chondroitin 6-sulfate is also present in various tissues. As evident from the name, 6-sulfate means the sulfur group which is present here in chondroitin 4-sulfate at carbon number 4. In 6-sulfate, it is at carbon number 6. So now I will be making the structure of chondroitin 4-sulfate. So now I will be making the structure of chondroitin 4-sulfate. Since I said chondroitin 4-sulfate is comparable in structure with hyaluronic acid, it also consists of its repeating dimer is one D-glucuronic acid and another is D N-style D-galactosamine 4-sulfate. Okay, now this D-glucuronic acid will be similar here. We'll make again D-glucuronic acid. It will be again similar. There is no change. Okay, it is also beta linkage, so here there will be no change. It is OH, H, H, OH. Now I will show the repeating dimer here. Okay, I want to show OH group here, H and COO negative. So this is our D glucuronic acid. Okay, now another repeating dimer of another unit of this repeating dimer is N-style D-galactosamine 4-sulfate. So we'll be making galactose. This and galactose and glucose, they are epimers at carbon number 4. Okay, galactosamine H, this repeating dimer. Okay, here it is a style group as it was here, style group CO CH3. Okay, it is H here and here it is H and OH. Here H, because why not OH here like it was in this N-style D glucosamine? Because glucose and galactose are epimers at carbon number 4. So the OH group at carbon at galactose will be upside. So here is the and since there is sulfate group in N-style D galactosamine 4-sulfate, here it is sulfate group, also will make a sulfate group here. Okay, 3 negative, and this alcoholic carbon H. Now since the bonding is again beta 1 3, beta 1 and 3, 1, this carbon number 1, 2 and 3. So the bonding will be between this beta 1 3 and it is between this OH. This OH group will be replaced. And I'm sorry, here it is also as I made a mistake here. This OH group will be, this is bonding is between the OH group. Okay, hydroxyl group, it will be hydroxyl group will be replaced here, not the hydrogen. So bonding is with the hydroxyl group. Okay, like this one here, it is bonding will be with the hydroxyl group and not with the hydrogen. Okay, so hydrogen will be represented here. So this is beta 1 3 and this is our chondroitin sulfate, chondroitin 4-sulfate. What happens in chondroitin 6-sulfate? If it is a 6-sulfate, this group SO3 group, it will be here represented at this carbon. So there will be that will be known as chondroitin 6-sulfate, and that's also present in some connective tissues. We'll be discussing about heparin. Heparin is a very well-known anticoagulant that prevents blood coagulation, and it is present in the blood, liver, spleen, kidney, etc., and lungs as well. This heparin helps in the release of an enzyme lipoprotein lipase, which helps clearing the lipemic plasma, turbidity in the lipemic plasma. So this heparin, it is made up of glucuronate 2-sulfate, that is, it is repeating dimer is glucuronate 2-sulfate and N-sulfo D-glucosamine 6-sulfate, N-sulfo D-glucosamine 6-sulfate. Now I will be making the structure of heparin. So heparin is a dimer. It is made up of it is repeating dimer or repeating disaccharide is glucuronate 2-sulfate and N-sulfo D-glucosamine 6-sulfate. Now I will be making the structure. glucuronate 2 sulfate. First, let us make the glucuronate 2 sulfate. This is similar to glucosamine. The difference is that only there is sulfur group or sulfate at carbon number 2. Okay. So there is bonding, alpha bonding here. Here it is sulfate group instead of acyl group at that it was in other, for example, N-acyl glucosamine. Okay. OH. It is the repeating dimer again here. I don't need to show it. Carboxyl group again here. So this is D-glucuronate 2 sulfate. D-glucuronate 2 sulfate. And now I have to make the structure of N-sulfo D-glucosamine 6 sulfate. Sulfur group at 6 carbon and 2 carbon as well. This is it. So there is this. This is not H here. Okay, it is a repeating dimer again. I will show you how here. It's H here, and it is this is N-sulfo. Okay, H, OH, H. Since it is glucosamine, that is, it is a glucose amine group, glucose molecule. Okay, H and bonding is between these two. This alpha bonding, and it is CH2. It is again sulfur group at 6 sulfate. That is sulfur group again here. CH2O SO3 negative. Okay, so this is our heparin. This is D-glucuronate 2 sulfate, sulfur at carbon number 2, and this is N-sulfo D-glucosamine 6 sulfate. Okay, so this is heparin. This is the structure of heparin. So this was my last lecture on the carbohydrates on this unit. If you find there is any other thing relevant to your studies, any other topic you want me to deliver upon, inshallah you will comment, and I will try inshallah to deliver a lecture on that as well. Till then, take care, study well. Fi amanillah.